We're looking at the perceptual learning activity for learning module 10B. In this activity, we're asked, should we retain the null hypothesis distribution or reject it and end up supporting the research hypothesis? Our first scenario, the z-test is a negative 0.02. You know, if the z-test is 0, that means that the sample mean landed right on top of where the null hypothesis distribution predicted that it should go, which is a win for the null hypothesis distribution. The null hypothesis is doing a great job. So we would retain it. We'd say great job to the null hypothesis and click retain. Now if the z-test is a negative 2.44, that means that the sample mean was 2.44 standard errors below where it was supposed to be based upon the null hypothesis distribution. And you know what? If the difference is beyond, for a two-tail hypothesis test, the difference is beyond a negative 1.96, going below the mean, or if it's above a positive 1.96, then we will reject the null. So this is definitely in the reject the null area. So here we're told the sample mean is 2.57 standard errors above the specified null mean. You know, a z-test, the definition of a z-test is the number of standard errors the sample mean is away from the null specified mean. So this is basically telling us the z-test is 2.57. And again, if the z-test is a big value, if it's bigger than 1.96, then we reject the null. Okay, so we get a z-test of negative 0.57. So, you know, again, think about the empirical rule. It says that 95% of the values will occur approximately within 2 standard deviations. And so if our sample mean is within that 95%, we're saying, hey, the null hypothesis distribution did a good job of telling us where it should be. On the other hand, if the sample mean is beyond that, it's outside that middle 95%, then we'll reject it. And one of the things that we recently learned is that the empirical rule just gives us an estimate. It's not actually plus or minus 2 standard errors that contains the 95%. It's actually plus or minus 1.96 standard errors. So this negative 0.57, it's within that 95%. So we're saying good job for the null hypothesis distribution, and we retain the null. Okay, so here we have, you know, a picture. This picture shows us that the sample mean is far away from where the null hypothesis distribution said it would be. You know, it says, you know, right here, 0 marks the spot. 0 would be the value that the null hypothesis distribution is specifying. You see this negative 1.96 and a positive 1.96. 95% of the values will occur between the negative 1.96 and the positive 1.96. And this is where the null hypothesis distribution says our sample mean should be. Our z-test is a negative 2.05. So you can see that it's on the outside of that boundary. And so because of this, we reject the null. Okay, here we're told the sample mean is 2.28 standard errors below the specified null hypothesis mean. So again, think about a z-test. The z-test tells you how far is the sample mean in terms of standard errors away from the specified null hypothesis mean. It says that it's 2.28 standard errors below, so that's a z-test of negative 2.28. And again, our boundaries are the plus and minus 1.96. So a negative 2.28, that's outside of our boundaries, so we'll reject the null. Here we have a z-test of 0.86, that's within the boundaries of the 1.96 to negative 1.96, so we will retain the null. Here we have a sample mean that's again outside the boundary. So, you know, we've got our null hypothesis distribution. You know, it says the sample mean should appear here in the middle, and the sample mean was 2.24 standard errors away. It was pretty far away from where the null hypothesis distribution said it would be. You know, so again, if we had hired like the null hypothesis distribution to tell us where will we find the sample mean, you know, for the sample mean to occur this far away, we're like, you know, that null hypothesis distribution didn't do a very good job. So, and because of that, we'll go ahead and we'll reject the null hypothesis distribution. Okay, a z-test of 0.04. Wow, that sample mean was pretty close to where the null hypothesis distribution said it would be. So we'd retain the null. A z-test of 0.94, again, it's within those boundaries of the negative 1.96 to the positive 1.96. And because it's right where the null hypothesis distribution said it should be, it's in that 0.95 zone, we will go ahead and retain the null. The sample mean is 2.41, standard is below the specified null mean. That's a z-test value of negative 2.41, and it is outside our boundaries of plus minus 1.96, so it's rejected. A z-test of 0.12, that's pretty close to where the null hypothesis distribution said the sample mean would be. We retain it. A z-test of 1.88, that's still within the boundaries of plus minus 1.96, so we retain. A z-test of 0.17, that's very close to where it should be. Remember, a z-test of 0 is like, wow, the null hypothesis distribution predicted it perfectly. A z-test of 2.57, that sample mean is far away from where the null hypothesis distribution said it would be, so we're like, it's not very helpful, that null hypothesis distribution, so we're going to reject it. We need a new model, something different to make our predictions. Z-test of negative 0.02, that's an awesome null hypothesis distribution, we'll retain it. 0.04, again, awesome null hypothesis distribution based on the z-test, we'll retain it. Our z-test of negative 2.1, so that sample mean is 1, 2.1, standard error is below the mean. It's in the reject zone, so we reject it. Z-test of negative 1.80, that's within our plus minus 1.96. Great job, null hypothesis distribution, we'll retain you. Z-test of 2.57, that's outside of our plus minus 1.96. Null hypothesis distribution did not do a good job of calling this, so we'll go ahead and reject it. Z-test of 1.88, that's within our plus minus 1.96. It's in that 95% zone. We go ahead and retain the null hypothesis. Z-test of negative 2.59, that's outside of our plus minus 1.96. We reject the null. Z-test of negative 1.80, that's within our boundaries of plus minus 1.96. We retain it. Z-test of negative 2.17, that's outside of our boundaries of plus minus 1.96. It is 1, 2.17 standard errors below the mean. It's in our reject zone. We reject. Z-test of negative 2.72, that's outside of the boundaries of plus minus 1.96. We reject the null. Z-test of 2.07, again, it's outside the boundaries of the plus minus 1.96. We reject the null hypothesis distribution. Z-test of 0.27. Good job, null hypothesis distribution. It pretty much called where the sample mean should be. We retain the null hypothesis distribution. We're told the sample mean is 0.87, standard error is above the specified null mean. That's a z-test of 0.87. That's clearly within our plus minus 1.96. We retain the null. Z-test of 0.86. We're going to go ahead and retain the null. It's within our plus minus 1.96. We're told the sample mean is 2.08, standard error is above the specified null mean. That's like a z-test of 2.08. So we go ahead and reject the null. It's outside of our plus minus 1.96. And there we go. So I'm going to go ahead and do this again. This time we'll be fast and just see how you do. Here we go. So z-test 2.26, reject. Z-test of 0.69, retain. Z-test of negative 0.26, retain. Z-test of negative 2.6, reject. Basically, it's a z-test of 0.54, retain. It's like a z-test of negative 1.15, retain. Z-test of 2.07, reject. Z-test of 0.94, retain. Z-test of negative 0.57, retain. It'd be like a z-test of 2.34, we go ahead and reject. A z-test of negative 2.03, reject. Z-test of negative 0.02, retain. A z-test of 2.43, reject. it's like a z-test of 0.03, retain. A z-test of 0.94, retain. A z-test of 2.08 above. So we go ahead and reject. A z-test of negative 2.05, reject. Another z-test of negative 2.05, reject. This would be like a z-test of 3.03, reject. A z-test of 2.57, reject. Z-test of negative 2.33, reject. A z-test of negative 2.03, reject. A z-test of negative 1.17, retain. This is equivalent to a z-test of negative 3.03, reject. A z-test of 1.06, retain. A z-test of 2.57, reject. A z-test of negative 2.05, reject. This is equivalent to a z-test of 2.65, reject. A z-test of 0.27, retain. A z-test of negative 2.72, reject. And percentage correct, 100%, 3.61 seconds to make the decision. We click next, and it gives us a completion code. So your completion code would be different for each quiz attempt, and you would type in this case, the 113 as your quiz answer, but when you do it, you'd have a different completion code to type in as your complete answer. All right, take care.